Welcome back to another edition of Mr. Yang and Mr. Doan's flipped classroom for Algebra 2 Trig. Today we're going to be working on rationalizing denominators and numerators as well as rational exponents. This is going to be part 1 of the video, and we're going to be working on rationalizing denominators and numerators first. So go ahead and fill in your notebook with all the stuff that you need right now, and we're going to go ahead and get started. Now, before I get started on rationalizing the denominator, there are a couple of vocabulary terms we need to review. First is the rationalizing factor. So, rationalizing factor. And this is the number that you're going to multiply by in order to rationalize a denominator that has a single term. And the single term must contain a radical, otherwise there's really no point in rationalizing the denominator. So in our first example, A, we have 3 over 2 radical 5. So in this case, our rationalizing factor is the square root of 5. We're going to multiply the top and bottom, the numerator and denominator, of this fraction by the rationalizing factor square root of 5. This allows us to basically get rid of the radical in the denominator. So here on top we get 3 radical 5. The reason for that being that the 3 is a coefficient on the outside of the radical, and it must stay on the outside. On the bottom we still have 2, and we have square root of 5 times square root of 5. Now you could write this as a square root of 25 because they multiplied together. But we all know by now that the square root of 25 is just 5. So we can write 2 times 5. At this point, all we have left to do is to simplify. So here, on top, it stays the same, 3 radical 5. And on the bottom, 2 times 5 is 10. And that's our final answer for the first example. Now, it's not always going to be that easy because there are times where the denominator has 2 terms. And in that case, we're going to have to multiply by something called the conjugate. Now, the conjugate is something that consists of 2 terms. And we're going to go ahead and go with some more general examples here. So, for example, if your denominator has a plus b radical m, something plus something with a radical, the conjugate is going to be a minus b radical m. Alternatively, if you have a minus b radical m, the converse, or the conjugate will be a plus b radical m. So we're going to use this in order to rationalize the denominator when we have 2 terms. So let's go ahead and zoom in a little closer here. For example B, this one's going to take a little extra work, so make sure you leave enough room. We have 4 over 3 plus 3 radical 5. With this one, we have this pattern right here where we have a constant plus some number outside the radical with the radicand on the inside. In this case, our conjugate is going to look like this. 3 minus 3 radical 5. Basically, kind of like the opposite, but more specifically, the conjugate. Just like in the first example up here, the whole purpose of multiplying by a rationalizing factor or a conjugate is to get rid of the radical in the denominator. So here we're going to get 4 times 3, but let's go ahead and write it all out. 4 times 3 minus 3 radical 5, the whole quantity. On the bottom, we get 3 plus 3 radical 5 times 3 minus 3 radical 5. Some of you might remember special patterns, which basically allow us to eliminate. I'm going to show you what is eliminated in this instance, just to show a little more work. So I'm going to multiply using my box method. 3 and 3 radical 5 on top. 3 and negative 3 radical 5 on the bottom. First box I get 9. Here I get 9 radical 5. Here I get negative 9 radical 5. And here I get negative 9 times 5, squeezing it right in. These 2 cancel out completely, leaving us in the bottom with 9 plus negative 9 times 5. Now this is all going to be in the denominator, so let's go ahead and simplify the numerator first. 4 times 3, 12, minus 12 radical 5. On the bottom, we have 9 minus 9 times 5. Here, we're going to get 12 minus 12 radical 5 all over 9 minus 45. You managed to simplify ahead of me. Just feel free to keep on going. But here we get 12 minus 12 radical 5 over negative 36. And because we have a single denominator, now we can separate this into two fractions. I'm going to go ahead and simplify right away. 12 over 36, that's going to be negative 1/3. Negative over negative, we get a positive there, and it's also going to be 1/3, more specifically with a radical 5 on top, so square root of 5 over 3. This would be our final answer. Now you could write it as a single fraction with negative 1 plus square root of 5 over 3. It depends on what you're being asked, but they are basically the same answer. Okay, so that is part B, and now we have one more step for this video. We're going to rationalize the numerator. So I'm going to go ahead and turn the page right now. Remember, if you have any questions or if you need to replay the video at this point as I get ready for the next section. So questions, work, and steps. Okay, very narrow columns, so let's see what I can do with this. For the numerator, I'm going to do another example where I end up with radicals in the numerator and want to get rid of them. Now you might be wondering, why are we going to do that in the first place? I thought we only rationalized in the denominator. It's something that you're going to see later in calculus where it's kind of necessary to actually rationalize the numerator. So it's good practice now, and let's go ahead and preview that. In this case, because we have a minus, our conjugate is going to be plus radical 3. Now notice I didn't fill in the first constant. The reason is because you should notice that the square root of 4 is 2. So let's go ahead and simplify that first and make our work just a little bit easier. So first off, if you recognize the pattern, we can actually skip a step. Here we know that it's going to be 2 times 2, or 2 squared, which is 4. We know that the two middle terms will cancel out, so we don't even need to bother with our box multiplication again. And here we know that square root of 3 will be squared, and it's going to be a negative, so it's going to be minus 3. On the bottom, we have 2 times the quantity of 2 plus radical 3. This is going to be 1 over 4 plus 2 radical 3. Now it doesn't look as pretty as the examples where we rationalize the denominator, but this would be the completed example for rationalizing the numerator. So this is it for part 1 of the video. We're going to continue on where we work with rational exponents. So go ahead, review the video if you need, or continue on to the next video.